Hello students, welcome to Opukwa e-learning. Today I'm taking you through chemistry shs1. My name is R Gyamfi. In our previous lesson, we learned about the arrangement of the elements into the main blocks, the 4 blocks, the SP, G and F blocks. Today we are moving a step further. We are looking at classification of the elements. The objectives of the lesson are as follows. By the end of the lesson, you'll be able to locate the main group elements and the transition elements. Secondly, you'll be able to name and give symbols of the elements under the following: alkali metals, alkaline earth metals, and the halogens. The classification of the elements is based on the type of subshells being filled. What I mean is, we base this classification on the subshells in which the valence or the outermost electrons fall in. And by this, we are going to have the main group elements, the transition elements, the lanthanides, and the actinides. These are the classification that we are going to consider. The first one, main group elements. And today we will dwell much on the main group elements. What are main group elements? They are elements in which the S and P blocks, or the S and P subshells of the highest principal quantum number are being filled. What I mean is, the elements whose valence electrons fall into the S and the P subshells, or both. These elements are classified as main group elements, and they are made up of about 8 groups: the S block and the P block. The groups that make up these main group elements are the group 1, group 2, group 13, group 14, 15, 16, 17, and 18. These groups make up the main group elements. That means the S block elements and the P block elements. Examples are sodium, magnesium, aluminium, carbon, nitrogen, fluorine, neon, etc. and etc. Why do we call these groups of elements main group? Why are they termed as main group? If we consider all the elements on F or in F graphs, these elements form about 80% of them. 80% of the naturally abundant elements are the main group elements. Also, if we consider human beings, the life activities, these elements are the most important ones, and that's why we call them main group elements, or that's why we term them main group elements. And also the chemicals we use are also made up of these elements. Let me go to the periodic table chart to illustrate what I'm saying. This is the periodic table chart, and I've said that the main group elements are made up of the S block. This is the S block. We have the group 1 and the group 2. They form the S block. And you want to the right here, we have the group 13, 14, 15, 16, 17, 18. And this is the P block elements. So we have how many groups in the main group? We have 8. 1, 2, 3, 4, 5, 6, 7, and 8. These elements form the main group elements. So as I've said, any element that has its valence electrons fall into either S subshell, P subshells, or both qualifies to be a main group element. The next classification is transition elements or metals. What are transition elements or what are transition metals? These are elements that have incompletely filled D subshells, or they form cations with incomplete D subshells. They are normally called the D block or the D series elements. Any element that has its valence electrons fall into the D shell, normally it's the 4s, 2 and the 3d. They are the transition elements, and they include group 3, group 4, 5, 6, 7, 8, 9, 10, 11. Sometimes we include the group 12 also there. Or if you go by the A group and the B group, they are the B families. So we call them group 3B, 4B, 1B, 5B, 6B, 7B, 8B. These elements are called the transition elements. And sometimes we also include the 2B. But the problem is, if you consider the group 2B elements or the group 12 elements, their valence electrons will have the D subshell completely filled, and therefore under strict sense they are not considered as typical transition elements. We also have other properties that are not exhibited by the group 12 or group 2B elements. For example, the transition elements are paramagnetic. But let's look at zinc, for example, which is a 2B or group 12 element. The atomic number is 30. And if you read the electron configuration, we'll have the argon core 4s2 3d10. So here, the valence electrons or the D subshell is fully filled. We have 10 electrons in the D subshell, and by the definition, zinc doesn't qualify. And when zinc forms an ion, a cation, it loses the 4s electrons. And when that is done, we are going to have the argon core and the 3d10. Here too, the D subshell is fully filled, and therefore it doesn't qualify to be a transition element in this sense. Also, most of the transition elements form variable oxidation states. But the group 2 elements, or the group 2b elements, or the group 12 elements, for example, zinc, it doesn't form variable oxidation. The only oxidation state is positive 2, and therefore it cannot qualify to be a transition element. But sometimes we include them because they also exhibit some of the properties possessed by the transition elements. Let's also go back to see the periodic table for me to illustrate the transition elements. They are here. They come between group 2 and group 13, or group 2A and group 3A. These are the transition elements. I hope you follow me. The first one, we have the first group. Here we have the scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, and you can sometimes include the zinc, or the group 12 or the 2b elements. So this is the first rule of the transition. We have others, the second rule and the third rule. But as I've said, today our emphasis is on the main group elements. The next classification is the lanthanide and the actinide series. The lanthanide and the actinide. These groups of elements, normally their valence electrons fall into the 4f and the 5f subshells. They are made up of 28 elements, 14 in each row. The first row is the lanthanide, and the second row is the actinide. And by WASI, we don't meet the transition elements. They don't normally come in our exams, so we not spend much time on the lanthanide and the actinide. But let's also take the look at the periodic table again for me to show you the lanthanide and the actinide. These are the lanthanide and the actinide. We have 2 rows or 2 periods for them. Example is the next one. We have the lanthanide, we have the cerium, we have praseodymium, and so forth and so forth. We have promethium, samarium, europium, gadolinium, and all that. And we have thorium, we have uranium. These elements are what we call the lanthanide and actinide series, or sometimes we call them F elements, F group elements, or the inner transition elements. In some books, they also call them rare F elements. So we turn our attention to the main group elements. These are some of the groups that we are going to consider for today, the main group elements. And our first group that we are going to consider under main group elements is the group 1 elements. The group 1 elements are usually called the alkali metals. That's the family name, alkali metals. Why are they given the term alkali? When they react with water, they produce solutions or substances that are strongly alkaline, or bases that are soluble, and that's why they are given the name. We have given them the name alkali metals, because they form strong alkaline solutions or bases that are soluble. They are found on the left edge of the periodic table. Let's just look at some of their properties. All the alkali metals have 1 electron in their valence or outermost shells, and to be stable they lose the 1 electron, so they all form +1 oxidation states, and they are all metals. They are unique. They are all metals. Unlike other groups where we have a mixture, metal, non-metals, and semi-metals. They are also good conductors of heat and electricity. That means they can conduct electricity well, and they can also conduct heat. Heat can pass through them well. One particular thing about them is that since they are metal, then they are very reactive. When exposed to air, they react with oxygen, and their shiny appearance gradually is lost. They tarnish in air by being exposed to air, by reacting with oxygen. So they are always stored under paraffin oil to prevent a contact between the air. They are metals with low melting points and low densities. If you consider them with, or if you compare them with the other elements, see that they are very soft comparatively. So they have low melting points and low densities among the metallic elements on the same period. These are few things now we can learn about the group 1 elements. In our subsequent lessons, we'll go into deeper or go details about the main group elements. The next group under the main group elements, the group 2 elements. These elements are also called, given the name, alkaline earth metals. That's their family name. Why do you call them alkaline earth metals? These elements also react with water to produce solutions or to produce substances that are strongly alkaline, as the alkali metals do. And therefore, they are called, or they are bases. Why earth metals? Is that the oxides and the hydroxides of these elements, being basic, are normally found in the earth crust, and hence the name earth metals. So they are bases, and that can be found, these bases are normally found in the earth crust. That is why they are called alkaline earth metals. They are reactive, but not reactive as compared to the alkali metals. They are in group 2, meaning that they have 2 electrons in their valence shell, or the outermost shell. So in order to be stable, they lose these 2 electrons to have oxidation number of +2. Are you following? So all the group 2 elements have or do have oxidation number of +2, because all of them have 2 electrons in the outermost shells. They are harder than the alkali metals. In fact, generally, if you are moving across the period from left to right, the hardness increases. And I'll give the reason in our subsequent lessons. So they are harder than the alkali metals. And once they are harder than the alkali metals, then we expect them to have higher melting points than the alkali metals. They are also good conductors of heat and electricity generally. Most of them are good conductors of heat and electricity, as the alkali metals do. They include, the first member of the group is what? Beryllium. We have magnesium. We also have calcium. Calcium is also there. Let me look at the board and tell you here. This is the group 2 element, the alkaline earth metal. We have beryllium, we have magnesium, calcium, strontium, barium, and radium. These are the alkaline earth metals. As I said earlier, all these are main group elements, but today we are only considering 4. So the next classification under main group element is group 17 or the group 7A elements, usually called the halogens. They are called halogens. Why are they given the name halogens? According to literature, they say they are salt formers. Mostly the salt that we have, they come from the halogens. They are located immediately to the left of the group 18 elements, and they are also very reactive. All of them form -1 oxidation state. Why? Because they have 7 electrons in their valence shell, so they need 1 electron in order to be stable. So they normally gain 1 electron to form or to be stable. So once you gain an electron, then the oxidation number you are going to bear will be what? -1. All of them do so. Then apart from fluorine, the rest also form different oxidation states. Chlorine, bromine, iodine, astatine can have different oxidation numbers. But fluorine cannot. Why? Fluorine is on the period 2, and the only available subsets are S and P. And I've told you all of them have 7 electrons in the outermost shell. So once they gain 1 electron, then the P subset is now full. And therefore, if more electrons are being added, it do not have a subset to accommodate. So that's the reason why fluorine forms only 1 oxidation state, that's the -1. But the rest, when you go to period 3, we have the S subshell, we have the P subshell, and the D subshells. So if more electrons are gained, then they can have subshells to accommodate or to occupy. As I'm giving, this is the halogens here shown by the periodic table. Now, the last one that we are going to consider is the group 18 elements. The group 18 elements. Our last group that you are considering today, under the main group elements, is the group 18 elements. Or in some books say group 8A or group 0. Most of them have 8 electrons in the outermost shell, with the exception of helium. So if you use the arrangement of the periodic table is from group 18, then we call them 18. But if you're using the A and the B, then we say the group number is group 8A. They are called noble gases or inert gases. Why? They are all gases. This is also a unique group. They are all gases. And why inert or why noble? All of them do have stable electron configuration. A stable electron structure. They all of them bear that quality. Helium is 1s2, so the only shell or subshell is what is full. Then you take neon. By the old arrangement, we are going to have 2,8. The atomic number is 10, or the 1s2, 2s2, and the 2p6. So the valence shell or the outermost shell is also what? Is full. And likewise, all of them have this stable outer electron configuration, and that is why they are given the name noble or inert gases. I mean, they are unreactive. They are noble in the sense that they are unreactive. they don't react. Generally, that is a general statement, because recently we have prepared compounds made up of xenon. So under severe conditions, some of them can be made to react. So take care when you are dealing or making a general statement or making a statement. So I'm saying that generally they are unreactive because they all have stable electron configuration. Where are they located in the periodic table? They are located at the extreme right, the right edge of the periodic table. Let us take a look at the periodic table again. These are the group 18 or group 8 elements. Group 8A elements. We have helium, we have neon, we have argon, we have krypton, we have xenon, and we have radon. We have how many electrons are there? 1, 2, 3, 4, 5, 6. We have 6 electrons that make up the group 18 or the inert or the noble gases. These are the groups that we consider today under the main group elements. We talk extensively about them in our subsequent meetings. So now, let me recap everything that we have done today. I hope we've understood it. I said that the topic for today is a periodic classification of the elements. And I said this classification is based on the type of subshells being filled. Either is S, either is P, D, or F. So once we know the type of subshells the valence electrons fall in, then we can tell the group or the category that the elements fall in. And here this morning we discussed the main group elements, the transition elements, and the lanthanines and actinides. And we dwell much on the main group elements. So we talked about group 1 elements called the alkali metals, the group 2 elements alkaline F metals, group 7 or group 17 elements also known as the halogens, and the last the noble gases or the inert gases. Before I take leave of you, I'd like to give you an assignment. Do this assignment and try to solve them. In our meeting, our next meeting, we'll look at what you have done about it. The first question: what is a main group element? Give names and symbols of any 4 main group elements. Assignment number 2. Without referring to a periodic table, write a name and symbol for an element in each of the following groups: group 1, group 2, and group 17. 3. Write the outer electron configurations for the following: alkali metals, alkaline F metals, and the halogens. The question number 3 is an application. Try to solve them and present your answers when we meet. And if you have any question, you can send them to me through the same website that you get this lesson. Thank you. It has been your facilitator, R Gyamfi. See you another time. Stay blessed.